Hey everyone, and welcome to another edition of the Snake Oilers podcast here at Risky Biz HQ. My name's Patrick Gray. Snake Oilers is the podcast series where we get vendors to come along and pitch their products so that we may better understand what it is that they do. This is a sponsored podcast series, and that means everyone you hear in one of these Snake Oilers editions paid to be here. So we'll be hearing from three vendors today: Wiz, Sandfly Security, and Permiso. Wiz, I mean, we all know Wiz. They've got they're the cloud security giant, but they've got some new products they want to talk about as well. Permiso is an identity security play, and Sandfly Security is a really interesting Linux security platform. And we're going to start with them. So let's start with Sandfly, a really interesting product, which is designed to detect attackers and malware on Linux machines. So that part sounds boring, but the interesting part is how they achieve this without an agent. To me, yeah, this is a far more interesting approach than just seeing yet another EDR equivalent for Linux. In essence, Sandfly logs into your Linux fleet to run diagnostics at configurable pseudo-random intervals, and it'll drop a bunch of little Go binaries on them that collect all sorts of system information, then bring that back for crunching. So here is Sandfly Security's founder, Craig Rowland, describing the product and how it works.
Right. So Sandfly basically is an agentless intrusion detection and incident response platform for Linux. The core idea is that we never want to leave any Linux system unmonitored. So we could work on systems up to 10 years old, all the way through modern cloud deployments. We can also work on embedded systems. So basically the Intel, AMD, ARM, MIPS, and IBM Power CPUs. So essentially one product can run on all these systems without deploying an endpoint agent. This makes it not only very high performance, but also extremely safe. We basically have a reputation of never tipping over Linux systems, which is very important, especially in critical infrastructure that often runs Linux.
Yeah, now, I mean, this is one of the challenges for creating like a EDR equivalent for Linux, which is that there's so many different kernels, right? There's so many different distros, there's so many different architectures, and trying to create something that runs nicely, that plays nice with every flavor of Linux out there is just, I mean, forget it, essentially, right?
Yeah, it's very difficult. And, essentially, once you start asking questions, someone says, hey, we do Linux EDR. Well, then you ask, okay, like you point out, what distribution, what kernel, what patches, what configuration. Some people have custom kernels that are specific for the organization. So, the marketing says this, but you find once you ask some questions on deploying an agent, it actually becomes this. And it becomes very risky to support all those different distributions. So you just can't. Essentially, if you tried to do QA with a traditional agent across all these Linux vendors, virtually all your time and money would be spent on just QA alone. You wouldn't have any development time. So What we did instead is we just got rid of the riskiest part, which is the agent. And by not tying into the kernel and not doing very risky things in terms of sweeping memory and stuff like that, we vastly expanded the visibility across all the platforms, but we also made the coverage, we feel, a lot more in depth in terms of what we can actually detect.
Okay, so why don't we walk through how this thing actually works, right? Because I did find this interesting. I mean, essentially, it's like, you essentially get creds for the machines that you're trying to monitor, and then you drop what you call sandflies on them, right? So why don't you actually walk us through, the means of access and then actually what your tool does?
Sure. So first of all, we chose the most ubiquitous way to access Linux, which is SSH. So SSH is on virtually everything, again, from cloud systems all the way to, $30 VPN you're buying off Amazon. Right. So we basically access the systems over VPN. We can use credentials you give to us. We could tie into a key vault, basically whatever it is. Typically, we can integrate in with the customer, how they manage it. At that point, we use a small Golang binary that has custom designed forensic investigation engines that are designed just to handle Linux. And then we use a series of modules we push over called Sandfly modules. And they are basically telling that remote engine kind of what we want it to look for. After we process that data and get what we need, the binary essentially destroys itself and then systems back to where it was before we even got there. This process typically takes 30 to 60 seconds every time we show up for a scan, and then we get off the box. And it doesn't really result in any type of serious performance or stability impacts in that remote system.
So what sort of data are you actually using these, little Go blobs to collect, right? And what sort of permissions do you actually need on the hosts that you're trying to monitor, right? Because I'm guessing that's a question in a few people's heads listening to this right now.
Yeah, it is. So essentially, we've broken Linux up into multiple components that are of interest to us from an attacker perspective. We're probably more accurately called compromise detection. So essentially, we will focus on processes, users, log tampering detection, directory and file activity, and something we call policy type checks. So essentially, it depends on what we want to do. So we're looking for processes that are acting suspiciously, maybe hiding or doing things that we know is malicious activities, such as how they exist on that system. We're looking at users from the perspective of, does this user appear to be maybe a backdoor or something odd about that user and what they're doing. We look at log files in terms of tampering. A lot of people think we're looking at log files. It's actually not what we do. We deal with Linux malware all the time. Linux malware goes to extensive lengths to avoid showing up in log files. So if you're only looking at log files, you're going to miss the worst part of Linux malware, guaranteed. But it will often tamper with a log file. So if you could see that a log file has been tampered with, they're trying to hide themselves, that's actually useful. And finally, the last two parts too, we look for files and directories that are suspicious, maybe being used for payload data or other kind of suspicious activities that, again, can indicate that system's compromised. Typically, we work a lot like an Ansible system in terms of we need to have access as a regular user, some type of sudo access to access some of these privileged areas. It's just the way Linux is. There are ways you can control what we do in terms of what our product can do once we get on the remote system. That's probably too much to get into in this interview, but there are other ways to restrict that as well through sudoers access and things like that. But that's essentially how the system works. It's a very fast, automated forensic investigation and intrusion detection tool.
Now, I mean, it sounds essentially what you've described is kind of like what a human being would do when logging into a Linux system to make sure it's okay, right? Like just having a bit of a poke around, having a look, is this right? Is that right? I mean, is that sort of where the concept came from, which is like, why don't we just sort of automate the steps that a human being would take when logging into a Linux system and curious about whether or not someone else is there?
Yeah, I mean, essentially, if you could automate a really pedantic Linux security expert that never misses anything, that's essentially what we've done. But more than just the intrusion detection, we've added some other components as well, because we also track SSH key usage, because SSH keys are frequently stolen and used in the move laterally across systems. So we want to track those. We also have a built-in password auditor to find weak default credentials that are often the first way people get onto a system. We also added on another component called agentless drift detection, which allows us to detect changes on the system that might not have been authorized. And finally, the last part, we also had the custom Sandfly detection as well. So it is almost like you have a full security team with all these capabilities built in the product. And we do that traditional EDR, but you have these other components as well of what a threat hunting team might actually want in terms of also addressing network security problems on Linux.
And I'm curious too, how does this thing go with appliances, right? Because another big problem for like Linux security agents is a lot of Linux in an org is actually some pizza box 1RU thing that is running Linux, but you can't really, crack it open and install stuff on it. So I'm guessing this varies case by case depending on the level of access that users can get via SSH to appliances, but are people actually using this to interrogate appliances?
Yeah, absolutely. Again, because we support Intel, AMD, ARM MIPS, and IBM Power CPUs, we can get onto most Linux devices, assuming they allow shell access, right? So for instance, we had some customers contact us because they found command and control servers run on their Synology network attached storage devices. Traditionally, you can never get an agent on those devices. We can run on them just fine. Things like Ubiquiti routers, we can run on those. We have one customer using us to watch IP cameras, again, running, MIPS processor, the, very tiny Linux kernels on it, but we can run on their systems just fine. And what we're finding, a lot of attackers actually are starting to go after these edge devices because they're frequently unmonitored. As you point out, it's almost impossible to get an agent on them. Plus, they tend to concentrate a lot of really important data. For instance, I mentioned the Synology NAS. It has a lot of data important organization, or, your VPN router, you're running everything through your Ubiquiti box, through the VPN. Well, I mean, all the data is being concentrated before it's being encrypted. That's a very valuable choke point for attackers. So a lot of attackers are deliberately going after these edge devices just because they know the security is so bad and they know that the monitoring is very unlikely to be happening there.
Now, I know you've got a couple of gargantuan customers that you can't name One of them is just massive, right? So I mean, perhaps you could share with us the sort of scale that you can handle, because that customer that I'm thinking about, I mean, the scale is certainly there, right?
Yeah. So, we have some customers with, I'll keep it vague, in excess of tens of thousands of endpoints, and then other customers in the thousands of endpoints. Generally, we attract very critical infrastructure as our initial customers, just because they have a need to watch a lot of different Linux systems with a lot of varied configurations and status. And they also need to do it again without risking any type of system downtime. They're the type of customers that if they go down, it would be like major news. So we're very, very careful about how we approach that problem. And these customers respect that, just because they understand the sensitivity of what happens if things go sideways on their networks.
I mean, I think the customer that I'm thinking about would probably best be described as critical internet infrastructure, as opposed to what we normally think about when we talk about critical infrastructure being pipelines or ICS, right?
Yeah, we do. We get a lot of interesting customers who definitely, like I said, they make up a lot of what people use every day in terms of what they consider the internet. We even have telcos as well using us. So again, if mobile infrastructure goes down, I mean, your cell phone's not working. It's a type of thing where it's very serious type of business. So we kind of run the gamut of what we're protecting right now.
Now, is that use case about security per se, or is it about detecting just general mistakes and, undesired config drift and things like that? Are people using it for sort of as a resiliency tool, or is it primarily just security?
We use both. So I'll give you an example. One customer in Europe got us initially to do the EDR component, and then we released the Sandfly, the SSH hunter, which tracks the SSH credentials. And they realized actually that their SSH key management was such a problem. They actually used us at first to clean up the SSH issues, and then they went back to the EDR side. And then we have other customers that are using us in the drift detection mode, because they might be running a bunch of systems that aren't being updated or changed a lot. So they just want to know if anything were to change. If you're running for instance, I bring up Ubiquity or the Net or Synology system. If a new process were to start on that system that you've never seen before, and the system hasn't been updated, you probably should be looking into that, right? That this could be a very serious issue. And a lot of malware on Linux won't drop onto the file system. It'd be a fileless malware. So just doing a standard file integrity check is not going to find some of these things. So we do have customers using us for different reasons, often all at the same time. So they'll use us for the EDR, they'll use us for the SSH. They'll have us looking for bad passwords, and then they'll use drift detection on certain configuration systems as well, just to make sure nothing's gone wrong.
That SSH key management cleanup, was that a custom job, or is that something out of the box?
Out of the box, you call it SSH Hunter. So what it currently does is it tracks, basically when we get onto a system, we're going to look at all the authorized keys files that we see users use. Authorized keys files on Linux are a notorious problem. They often get stale keys, old keys put all over the place that nobody knows about. So we'll index those, and we basically will track who's using them, where they are, how long we've seen them, and some other criteria as well. We recently introduced a new feature too called SSH Security Zone. So you could actually set up groups of systems by tags. You could say, these are our production systems, and these are the 10 keys allowed to go on those boxes. So if an 11th key were to show up there, you would get an alert. So you know that someone has added a key to your production boxes in this example, just to show. So we get customers using that as well. And a lot of times we do other things as well, such as we'll just look at your system to see, do we see private keys lying around? Like, what one person reported, we found hundreds of private keys lying in a world readable directory in one of their systems that was left behind by a management product. They're like, well, how to get there? I'm like, I don't know. We're just telling you they're there, right? You need to figure that out, how they got there, or even just unencrypted keys. This type of stuff, it's a really big problem, because what happens is the attackers, they'll get onto a first box. It doesn't matter how they get on, but then they will then search that system for credentials, right? Either a bad password or typically an SSH key. And if they find a private SSH key that's unencrypted especially, they're off to the races. They're going to use that with transitive trust to start moving between your network. And then they'll keep doing that once they get on other systems. So it's very, very important to know SSH access and kind of what's going on there.
All right. Well, Craig Rowland, thank you so much for joining us. The company is Sandfly Security, and you can find them at sandflysecurity.com. Fantastically efficient pitch. Really enjoyed it, and we'll talk to you again soon. Cheers.
Great. Thanks a lot.
That was Craig Rowland there with a chat about Sandfly Security, a really interesting Linux security product, and you can find them at sandflysecurity.com. It is time for our next snake oiler now, Permiso. Permiso is an identity security play, and identity security products are really a big thing at the moment. The idea with Permiso is that it can create an identity graph from your identity directories and then an activity graph that allows them to identify identity-based attacks and compromises. So here's Jason Martin from Permiso to walk us through their platform. Enjoy.
Yeah, so we plug into the control plane of your IDaaS, your SaaS, IaaS, and PaaS environments. And then we're looking at what entities are in that environment and how they're configured to access your environment. And then really more importantly on the threat detection side, what are they doing? And a really important part of how we do this is read-only. We don't want to be another vector of over-permissioned access into any of these environments. So read-only in different, let's say in Okta, it might be via a read-only admin token. In Microsoft's ecosystem, it might be a delegation via an app. In AWS, it's a role that we assume that has a specific small set of permissions we need to do what we're doing. Once we're plugged into the control plane, we create an entity graph. So we understand what is in the environment. And then we create a activity graph. And these are the entities that are actually operating in the environment. The detection comes in because we correlate the identity across boundaries. So for example, if a user is coming in via SSO and accessing a SaaS, IaaS, and PaaS or PaaS environment, we're going to try to attribute that back to the ultimate identity at the SSO layer. If a vendor is coming in and assuming a role in, say, AWS, we're going to attribute it to that vendor. If a user is coming in via local access into any of those layers, we're going to attribute it to that. And that allows us to profile what behavior looks like normally for that identity, what access looks like normally for that identity. And then once we're able to do that, we're also able to correlate all activity kind of across that layer cake of technology back to that identity in a construct we call session. And then we inspect that session for behavior that may be exposing you to risk, specific matches against content that we have around what threat actors are doing in those environments, or just anomalous activity based on our machine learning and deep learning modules. Very high focus on reducing the overall alert volume because instead of inspecting things on an event-by-event basis, we're looking at the aggregate session of activity. And again, not just in the one layer of the infrastructure or SaaS, but across those environments.
Yeah, I mean, it seems like this is a direction that vendors are moving in now, right? Which is to just do that piece which ties it all together, which is, okay, this token over here that's doing this thing, what's the point of origin? Where's the authentication event that led to that token being created, and then attributing that particular, token or whatever it is back to an authentication event and back to an identity. So it sounds like that's a pretty key piece here.
It is. And I think if you think historically, people would try to do this in their SIEM and they'd be doing it after the fact, right? They know an account has been compromised, a credential has been leaked, and now they're going to go reconstruct all this in the SIEM. What we were focused on 4 years ago was how do we pull that paradigm left towards the events and the activity that's occurring? And how do you do detection at scale with that construct, which is non-trivial, as you know, in the cloud is very, very, very noisy. It also helps analysts, right? When you give them an alert, now they know what's the identity involved, what is historical activity, what's historical access, whether alerts have they triggered in that environment, what entitlements they have, what entitlements are they using, is the use of those entitlements irregular for that entity, things like that. And giving that one place allows them to quickly triage the alerts we generate.
Well, I mean, that's the machine learning bit, right? Like, it's not too hard to profile these sort of accounts, right? Like it's actually not, which is kind of like why it's surprised me that it's taken so many years for people to kind of offer this, because we saw, I think, and I've mentioned this on the show so many times, but we saw Rapid7 had a product for Active Directory. I can't remember what it's called, but they had a product that did this for Active Directory like a decade ago, longer. And, finally we're getting there in the cloud. But I mean, I'd imagine that the detections that you're doing on some of these are going to be really reliable detections, right? When you've got like a machine-to-machine account that all of a sudden starts doing stuff for the first time. I mean, that's going to stand out.
Machine-to-machine, vendor-to-vendor. I think those vendor-to-environment, those tend to be easier to profile, even though they're high volume. people.
But people are weird, right? So they're harder to profile because, yeah.
Both from an access perspective, especially with remote work now being so predominant, but also just activity. On a given day, I wake up and I do things different, right? Machines are programmed to do certain things, and that's the easy part. I mean, like, look at anomaly detection on most of the modern IDPs. They fire on like 20% of the human sessions that occur. I get sessions from our IDP provider that are flagged as anomalous, even though I work out of this office every single day. We've had to do it. It seems easy, but the human side definitely complicates it, right? And then if you think about, look, the modern cloud, the difference between an on-prem world, right? What happened in AD? I got assigned to a group, but it was still my user assigned to that group, and I was operating the environment. Not too hard to attribute what Jason was doing in an on-prem world. In the cloud and SaaS world, I am oftentimes coming in through single sign-on, and then via a SAML transaction or credential assumption in some way, I'm operating with a credential in that environment. All my activity is tied to that credential. That credential may be shared in some of our largest customers with hundreds of concurrent users, like in the developers, SREs, and things like that. And so it's very hard to profile access and anomaly on a shared role or credential. You have to be able to tie it back to the individual user, and you have to be able to join, what is AWS, very voluminous CloudTrail logs, back to a singular entity. That's Jason, who came in via Okta, clicked on that AWS role, operated for 14 minutes, did these, 17 or 70 things, and be able to know that that's normal or abnormal for Jason. That's non-trivial in the cloud.
Yeah. Now, another thing that you're doing is ISPM. I actually had an interview recently with the co-founder of Spera, which was an ISPM company that was later acquired by Okta, and that's now their ISPM product. So I feel like I've, recently spoken to someone about how ISPM works. But I mean, the goal there is really to look for, accounts that are misconfigured, accounts that shouldn't exist. I think he gave the example of stuff that was synced into Entra, accounts that are like 20 years old that have been sitting in Active Directory that get synced into Entra with no MFA and whatnot. And, you really need an ISPM product to find those things and MFA gaps and all that sort of stuff. So I'm guessing that's what you're doing as well?
Yeah, I mean, to your point, though, we jokingly say it's like bring your own adversary when they move from on-prem to the cloud, because oftentimes they bring in not just bad hygiene, they bring bad actors into their cloud environments. Well, look, we started 4 years ago, we started centrally focused on threat detection. We felt like that was the hardest thing to do at scale across these environments. As we detected breaches, our customers would often come back and say, okay, look, I need to remediate the cause of this breach. And that inherently always comes back to posture. Right? It doesn't matter if we're talking about, on-prem, IoT, edge, cloud. The very first thing you generally want to do is know what's running in the environment, how it's configured, and if it's exposing you to risk. So we started on the threat detection side, and now over the last year and a half, we've focused a lot on posture. But posture is also important for threat detection, right? If I see activity from Paul and I see activity from Patrick, but Patrick is much more vulnerable, maybe has a set of toxic combinations that'll lead to privilege escalation or large sets of entitlements, or doesn't have MFA configured, even though the activity is the same, I'm going to point and rate the severity of that alert much higher than, say, Paul's. I mean, obviously you should pay attention to Paul's activity, but SOCs, right? They're doing trade-offs constantly, and they need to know that. So we felt that the marriage of posture with runtime was super important there. And then subsequently, as
it gives you context, right? Which is like, this user's doing something funny, and it's also one of the ones that's like over provisioned and like a little bit, difficult to secure. So maybe we want to pay more attention to this one.
Yeah, and then imagine how do you do proper posture and privilege analysis if you don't actually see the atomic level activity for that entity in the environment, right? You can have gross assumptions that a user comes in through their federated provider and clicked on AWS, so they're an AWS user. Maybe you may say they used S3, but without examining and correlating that, okay, Patrick does list bucket, but he has broad permissions to S3. It's really hard to give, I think, really informed and intelligent least privilege recommendations to your customers. You have to combine the two.
All right. So what sort of customers are buying this solution? Because I've spoken to others and they're like, well, this is mostly at the moment, larger organizations that are multi-cloud. They might be using more than one IDP, and they do not have a hope, a snowflake's chance in hell of trying to do this themselves. And that seems to be where this market is kicking off at the moment. Has that been your experience as well?
I think early on, what happened, nobody believed that we needed this. To be honest, like nobody believed we needed this solution. 3 years ago, identity wasn't even in the top 10 for CISOs. Now it's like number 2, number 1, arguably. We plugged in to environments that were breached. So once you got breached, they realized they had the CrowdStrikes of the world, and they had the Wizzes, they had SIMs, they had all these other tools, but they were still getting breached to this identity vector. And then the secondary profile that was buying us was breach adjacent, right? Your neighbor just got popped by Scattered Spider, Lucre 3. Now you're worried about it. And they were a good company. They had all the right tools and processes. You respected them. They still got breached. What did they do? They bought Permiso. Okay, so now breach adjacent buying. As the market's evolving, we're starting to understand more around proactive purchasing. So I would say on the proactive side, our customers tend to be very mature on their risk assessment process. And they look at overall, what are the set of controls I have for identity risk? Okay, I have single sign-on here. I understand my inventory. On the machine side, I don't really have anything. I need to start looking there. And they kind of quantify that risk annually versus like reacting to the market or reacting to what's happening around them. And we're starting to see more interest in that way. And how do I quantify that? Inbound RFIs, inbound inquiries, less of us having to go out and constantly educate the market, and the market's starting to kind of come to us. A lot of times I think you accurately described it as fairly complex environments, fairly large, Fortune 1000, several thousand employees, has a security operations center, is fairly sophisticated from a security governance perspective, multiple IDPs. Sometimes we see 4, a customer IDP, multiple enterprise workforce IDPs. They're both on-prem and in the cloud. And in the cloud, they're multi-cloud. And then anywhere from 50 to 70 SaaS applications deployed. And they can't answer. Snowball, chance in hell. Yeah. It's probably a good analogy there.
All right. Well, Jason Martin, thank you very much for walking us through Permiso. It's great to get an update on what's happening in the identity space, which is, truly a category that's kicking off at the moment. All really interesting stuff. Thanks again.
Thanks for having me, Patrick. Appreciate it.
That was Jason Martin from Permiso there with a pitch for their identity security solution. And you can find them at permiso.io, permiso.io. It is time for our third and final snake oiler today, Wiz. Now, Wiz is a relatively new company being founded in 2020, but it's grown rapidly to become worth roughly $11 gajillion. And Wiz's rise, I guess, it can be best described as meteoric. But, I've never actually been that clear on what it is they actually do. So when they reached out and wanted to book a Snake Oilers segment, I thought this was an excellent opportunity to learn something. Jung Lu is a Senior Director of Product Marketing at Wiz, and she joined me to give us the condensed pitch for the overall Wiz platform and to have a more detailed conversation about the code security, and secrets discovery product that they've just launched. So here she is.
So the way to think about Wiz is we are a cloud security platform that helps our customers gain full understanding of everything that is running in their cloud environment. And then we help them to prioritize the most critical risks. So not only looking at vulnerabilities, which an organization might have millions of, not only looking at misconfigurations, which they also might have millions of, and not only looking at things like sensitive data, which might be all over their entire environment, but really helping organizations uncover the full attack paths into their cloud environment that, if exploited, would really lead to significant business impact. So imagine things like a vulnerable container that is publicly exposed to the internet with a known exploit that then has excessive permissions that would allow an attacker to move laterally in the environment and find things like sensitive data within the environment. And then from there, what we help organizations to do is from that very prioritized risk, then we help organizations to remediate it rapidly. And we do this by actually democratizing security out to the teams that are responsible for that part of the infrastructure, right? Because if security finds an issue in cloud, they oftentimes are not able to actually take the action. You need to find the part of the business that owns that infrastructure to be able to remediate it. So we send those directly out to our customers or directly out to those application teams. And from there, they take the right action and they're able to remove that critical issue and proactively reduce the attack surface in cloud.
So basically, you've got vuln scanning, you've got misconfiguration scanning, you've got an understanding of permissions, and you've got an understanding of what's available. So you've sort of got elements of CASM, you've got elements of vuln scanning, elements of configuration scanning and whatnot, and all into one. That's the platform pitch, right?
Exactly. It's all of the risks across layered on top of the actual graphical understanding of your cloud environment.
Okay, right. So that is the core platform. Now you are making this push to be like a multi-product company. One area that you're pushing into, and this is interesting because one area you're pushing into is the code scanning part of it, right? So looking for vulnerability, shifting left and trying to identify vulnerabilities before they're deployed. Why would someone want to use Wiz's version of this when this is already an existing market with existing tools? What's the advantage of trying to use a tool that's created by a cloud security platform like Wiz?
Yeah, so I think taking a step back first, I think there's really two sort of technology stacks that we've had in place as we think about this landscape, right? There's been the cloud security tech stack, which looks at what's actually running in the environment. And then oftentimes you have then the application security stack that you're using to have a better understanding of the application, a better understanding of the code, as well as the entire pipeline that builds the cloud environment. And they're oftentimes not only silo technologies, but run by different teams as well. And there's not enough communication or collaboration between them. And so as we think about cloud, right, we have amazing context of what's truly important in the environment. So we have a great way of prioritizing. However, actually remediating is harder because you have to trace it back to the source. You have to trace it back to those teams. And now you're much further removed from the developer actually in the act of coding. On the flip side, on the AppSec side, you have that amazing feedback loop with developers, right? You're finding things early. You can bring it back to them before it truly impacts the environment. But at the same time, it's difficult then to prioritize because if you say scan your code repository for secrets, you'll find many of them in there. But you don't know which ones are truly important to fix because you lack the context of what's actually running in the cloud environment. So it's difficult to say this particular secret, if you expose it, this will lead to an actual admin role in your cloud environment. And this admin role then has access to sensitive data that is in your cloud as well. So it's difficult to track that entire attack path. So what we're trying to do with Wiz is really drive that linkage, right? And actually drive the convergence of these two different stacks. So it's not anymore about a set of risk scanners that run in code, then a completely set of scanners that run in cloud, but really the same set and really the ability to write the same policies that enforce what good looks like in your organization.
Well, and I guess it's about, if you've got that unified, because Wiz is well known as like the cloud dashboard company. And I guess being able to light up a dashboard with some sense of context and prioritization around some security problem that's been committed into code, you're kind of taking, you're notifying people outside of the dev team at that point, right? People who might be more empowered to act, shall we say?
So I think it's both, right? I think we're increasingly seeing developers themselves want to take the right action, just oftentimes lacking the tools in order to do it. So we actually, when we think about the experience for code, we build it for the security team itself, which of course wants the UI. It's an extension of the interface that they already know. But then when it comes to developers, it's actually more about meeting them in their particular workflows. So let's take that example of an exposed secret that leads to a identity in the cloud. We actually want to provide that feedback directly to the developer as early as we can. And that's it within the IDE itself. So we can say, hey, this line of code that you just wrote, if you deployed it, it would lead to a secret or lead to access in the cloud environment.
So hang on. Just let me, sorry to cut your flow there, but that's an interesting idea because it's one thing, isn't it, to put an alert in front of a developer that says you're about to do something bad versus you're about to do something bad and here are the precise consequences of that. Exactly. I mean, it seems like that's what you're trying to get at there.
Exactly. I think the problem has never been that we have information for people. In fact, I think we have too much information, right? It's really the context of what truly matters that has been lacking. And we really think that because we have the cloud context for what's actually there in cloud, we can bring that back to developers, and it gives them the confidence to make changes. Because otherwise, if you just say, oh, you exposed a bunch of secrets, like, what am I really supposed to do with that?
Now, you've talked a lot about exposed secrets. What other sorts of issues will this, code scanning product from Wiz identify? Is it going to pick up on all your usual sort of bad developer issues where you whack them on the nose with a rolled up newspaper, that sort of thing?
Well, we definitely don't want to do that, right? We're trying to improve the collaboration between developers and security teams. But the best way to think about it is really every single scanner that we run in Wiz for cloud, we're extending into code as well. So looking for sensitive data, we can look for it now within the repos, vulnerabilities, same thing. And actually, the other thing that's really interesting is the extension of what cloud security posture management even looks like. Because as you have all of these tools, like let's take GitHub, for example, there are a lot of different configurations that you can make to GitHub itself. And so we're actually also extending our configuration checks into the tools that you're using within your pipeline. And I want to give one more example, which I think is really interesting. And hopefully it's not too much PTSD for folks on this call, but I think many of us remember the Log4j incident. Right. And so organizations were immediately looking for, where do I have Log4j in my environment? And because of the cloud now back to code traceability, we can actually help organizations not only find which ones exist in their environment, but then also trace it all the way back to the source. So let's say I found Log4j running in a container image that I have running in my cloud. I can actually then trace that container image back to the registry. I can trace it back to the Docker file. I can trace it back to even the commit. And what Wiz can do now is actually create a one-click pull request that gets it back to that repo where we found that it was introduced, and gives the opportunity for a developer to say, hey, yes, I want to fix this. I want to patch this, and then click that merge button.
Now, it seems like it might be too early. We had this conversation before we got recording, but it might be too early to call this like a market consensus on how this sort of stuff should be done. But it's probably worth noting that some of the companies that are better known for this sort of code scanning stuff, they're starting to sort of build out they're starting to build right as you build left. So it seems like there is a view forming that in order to make this stuff as useful as possible, it needs some sort of visibility beyond just the point that code is committed, right?
Exactly. I think that's really the key, is the context, right? And giving that same context to everyone so that they're able to take the right actions. So I think, some folks, as you mentioned, are going left to right. We're doing what we call middle out, which is from the center of what's actually running and then shifting that left. And I think ultimately what we hear is the practitioners, but also CISOs just saying like, hey, it doesn't actually make sense anymore to run all of these very different or run the same set of risk assessments in two completely separate places and have two different teams then taking action on them, right? It's just not an efficient workflow for anyone that's involved in cloud. And it's actually slowing down our ability to move in cloud.
Now, we've got a couple of minutes left, so I do want to briefly touch on another product that you've launched, which is more about infrastructure monitoring. So this is something that I believe it started off monitoring Kubernetes stuff, but now it's like it can be across different technologies and whatever. And same thing again, trying to have that unified view of actually what's going on, detecting lateral movement, things like that, weird, funky processes spinning up where they shouldn't be. That's the basic idea.
Yes, exactly. So in cloud, you can't remove every single risk. So you do need to have that real-time threat monitoring in place. And I think what's also interesting about cloud and sort of why all of these products make sense together is the fact that whether you find a risk in the cloud environment that you want to remediate quickly, or you contain an incident in your cloud, and you want to then find the root cause of it so that you're able to remove that entire class of issues in the future, it all comes back to really understanding and being able to correlate from the code onwards, right? Because that's how we're going to actually continuously improve the entire operating model and make sure that we're not just playing whack-a-mole in the production environment, but rather really helping our organization to remove these classes of issues.
All right. Well, Jung Lu, thank you so much for joining me to walk me through all things Wiz. I think, as I said at the intro there, it's a company that obviously we all know about, but I haven't known enough about it really. So it's been great to get a bit of an education. A pleasure to have you. Thanks.
Thank you so much, Patrick.
That was Jung Lu there from Wiz, and you can find them at wiz.io. And that is it for this edition of the Snake Oilers podcast. I do hope you enjoyed it. I'll be back soon with more Risky Biz for you all. But until then, I've been Patrick Gray. Thanks for listening and watching.